Assalamualaikum. In this video, I'm going to be discussing Split TCP and how it can improve connections in challenging networks. Alright, so we're going to be discussing the difference between normal and Split TCP, logic, mechanism, advantages, disadvantages, as well as the future of Split TCP, and we're going to be concluding that all. To understand why we need Split TCP, we first have to look at normal TCP. TCP is the backbone of the internet and it's designed to be end-to-end, which means it uses one single unbroken connection. The main rule for managing traffic is simple. If a packet gets lost, it assumes there's congestion and it slows down the speed at which it transmits data to avoid further congestion in the internet. The problem with normal TCP is that it cannot differentiate between a loss from interference or loss from congestion. So we have lossy links such as wireless connections. They have more packet loss via interference, and uh, because of that, TCP thinks there's congestion and slows everything down, which makes the internet feel incredibly slow, even if the rest of the internet, the wired part, is perfectly fine. The solution to that problem is split TCP. By definition, it breaks one end-to-end TCP connection into two or more separate connections at an intermediary node called a proxy. This is usually done by the ISP at their gateway. So the proxy basically terminates the connection from the server to the mobile host. It starts a new separate connection and then acts as a bridge, reading data from one connection and writing it to the other. As you can see in the diagram, this creates two separate independent connections. One connection from the stable server on the internet to the proxy, a second connection from the proxy to your mobile device over the unstable wireless link. So let's talk about the wired part between the server and the proxy. The proxy pretends to be the end user, and since it is on the fast, stable internet, it gets data from the server perfectly. As soon as a packet arrives, the proxy immediately fires back an acknowledgement, and since these acknowledgements get back super fast and never see any packet lost, TCP thinks the connection is amazing and it rapidly expands its congestion window, which basically means it dumps data to the proxy as fast as it possibly can. Now the wireless link between the proxy and the phone. The proxy has stored all the data it just received and it takes on the job of being a server to the phone. When it sends a packet and if the packet gets lost, the proxy notices it and it just resends that one packet. Since this resend is a local event, the original server is completely unaware of it, and the errors on the wireless link are handled locally without ever triggering the main server's congestion control and forcing it to slow down. Moving on to the advantages of split TCP, we can get a higher performance and throughput on wireless and satellite links. You can also use a completely different specialized protocol for the wireless part if you want, and link isolation basically means that the wired link does not slow down when there are errors on the wireless link. However, there are significant disadvantages. Firstly, we're violating the end-to-end principle. The server gets an acknowledgement from the proxy before the data has actually reached the user's phone. So if the proxy crashes, the data is lost and the server thinks it was delivered. Secondly, we have security risk. The proxy is basically a man in the middle. It has to read the data from one connection and write it to the other. If the connection is not encrypted, then the proxy can read and even change everything that is being sent. Lastly, we have state management. Since the proxy is a single point of failure, it must also maintain state for every TCP connection. Talking about the future of split TCP, the biggest hindrance is encryption because it makes split TCP obsolete, as a proxy can't manage data it can't read, and encryption is designed to stop this. So the first evolution is performance enhancing proxies, which instead of reading the data, read the headers, which are unencrypted, and manage the flow. The second evolution is quick, which does the same thing as split TCP, however in a UDP protocol and in a more modern and secure way. Lastly, we have the edge computing, where we move the server application to the edge, which in this case is a proxy, and the proxy is basically running the application by itself. To wrap up, Split TCP is a powerful technique used to solve the problem of slow performance on high loss networks. It works by isolating the bad part of a link and letting the good part run at full speed. The key takeaway is its trade off. We give up the pure end to end design of the internet to get a performance boost in environments such as mobile network infrastructure that we use every day. Thank you for listening, and that's all.